Hello everyone. Myself Janish Shah, Assistant Professor at LJ College of Engineering and Technology. I'm going to teach you data structure. So let's start. The question is, sir, what we are going to learn today? So here is the outlines. First, we understand what is data structure, its basic understanding concept, and then the last topic is types of data structure. So let's start with concept understanding of data structure. Data structure. Right now, there's one big question mark coming in your mind. So, what do you mean by data structure? So, many of my students, what they did, they just separate two words, data and structure. So, the question is, what do you mean by the data? Sir, it is very much easy. Anything that generate the or useful for the information, the thing is known as data. And right now we are using so many data like 2G, 3G, 4G data pack on internet through Gmail, files, images, videos, so many things, right? So data structure is nothing but it is a data plus structure. Okay, I'm not confirming that data structure is data plus structure. Okay, I'm just saying that what my student told me in my previous sessions. Okay, so another definition they can say like structured data. Okay, someone told me so it's a easy processing of data, and another word is arrangement of data. So what is data structure? It is easy processing of data. Is it useful to arrangement of data? What is it? Before understand it, please focus on this concept understanding of data structure. Messy wardrobe. Now, I'm going to give you one example like with messy wardrobe. In your home, if your wardrobe is not properly arranged, what happened? You are not able to find perfect thing from that, and you're shouted on a mom. That mom, where is my shirt? Where is my jeans? Where is my watch? I'm not able to find anything from this. And then mom came over there, find the thing and give it to you. But she also guide you that you should arrange your wardrobe properly. So you can find so many things very easily. So what happens if you had not arranged your wardrobe properly? You're not able to find things. Okay. Now the next, a perfect wardrobe. Let's see what happens with the perfect wardrobe. Here in the image, you can see that lady put her bag into the cupboard at a very particular place. So what happens when she come on the next day, she can find her purse very much easily. So what is a good practice? To arrange your wardrobe properly, just to bring out the things from it very easily. So is it to find things if you have arranged your wardrobe properly? So that this is nothing. This is data structure. Yes. In data structure, you are just arranging your data in the memory in a very efficient way so that you can retrieval can be easy. Because at the end, what we need to do, we just need to processing the data, we just need to retrieval the data, we just need to store the data. So to store the data in a way such that retrieval can be easy, that thing is known as data structure. In a technical terms or according to the book, data structure is a mathematical or logical model of particular organization of data in memory. A mathematical model that shows that how to organize your data, how to organize your data so that the retrieval process can become easy. Okay, now next one is the data structure is a portion of memory allotted to a model in which required data can be arranged in a proper fashion. It is very much easy to understand it. If your data is properly arranged, then you can do anything with that data, either or you can do any operation on data, because for each and every operation, what you need data from the memory. So retrieval process from the memory become easy. Okay, good. Now moving forward to the next topic is types of data structure. So here you can see the hierarchy of types of data structure. Types of data structure. The data structure is divided into two different parts. The one is a primitive data structure, and second one is a non-primitive data structure. What happens in primitive data structure? First, students tell me that have you ever listened this word primitive in your C or CPU subject? Yes. So that primitive means basic data types. Have you ever heard primitive data types, basic data types? Yes. Yeah. What are the basic data types? Integer, float, character. Okay. So these things are, or these data types are known as basic data types. Why they are known as basic data types? Because computer can easily understand it. Array is a derived data types. Okay. Structure is a user defined data types. Okay. Because using structure you can define user defined data types. Okay. So that means there are three types of different data types are there: primitive data types, derived, and user defined. Now we are just focusing on the primitive data types. If you are writing integer a, that means computer can easily understand that the a occupies 2 bytes in the memory. Okay, because compiler can easily understand what is mean by integer, what do you mean by float, what do you mean by character. So here the primitive data structure is nothing but a data structure which is directly operated by machine level instruction. Computer can directly understand it. That data structure is known as primitive data structure. The types of primitives are integer, float, character, and boolean. On the other hand, the non-primitive data structure, it divided into two different parts. One is linear, second one is a non-linear. In linear, examples like array, stack, queue, linked list. In non-linear, tree and graph. In our subject, we are going to study about each and every data structure in detail. Okay. Now next, primitive and non-primitive data structures. Okay. So I have already told you about the primitive data structure. Do you remember it or not? What do you mean by primitive data structure? Primitive data structure, that means a data structure which is directly operated by machine level instructions. That means computer can easily understand it. Machine level instruction given by the compiler. The compiler can easily understand it. Okay, that thing is known as the primitive data structure. Data structure that are directly operated upon by machine level instructions are known as primitive data structure. Examples like integer, float, character, and boolean. Okay, now the next topic is non-primitive data structure. It is very easy to understand. If in primitive data structure, the data structure is directly operated by machine level instructions, so then in non-primitive, it is not operated by machine level instructions. Okay, so non-primitive, the data structure which are not directly operated by machine level instructions are known as non-primitive data structure. Examples are linear and non-linear data structure. In linear, array, stack, linked list, queue. In non-linear, graph and tree. Okay, so let's see about the linear and non-linear data structure. Students, tell me what the first thing comes in your mind when you listen a word linear. Linear means sequential. If the number is 1, 2, 3, 4, 5, 6 stored in a memory, 1, 2, 3, 4, 5, 6 stored in a memory in a sequential fashion, then it becomes linear. Okay, now tell me, in examination hall, if you're sitting according to your roll number wise, 2, 1, 2, and 3, then 2, roll number 2, in front of it, him, who seated? Roll number 1. On the back side, roll number 3. Again, that means roll number 2 has one neighbor. Roll number 2 has one neighbor in front of him, one neighbor on the back side of him. This thing is known as adjacency, relationship of adjacency, where each and every element has only one predecessor, one successor. So again confused, what do you mean by the predecessor and what do you mean by the successor, and what is the meaning of adjacency? I will show you. Wait for a minute. Now consider an example for the roll number 1, 2, and 3. So for 2, 1 becomes 1 becomes predecessor and 3 becomes successor. Okay, now is it very easy to understand that 2 has only one neighbor 1 and only one neighbor 3 on the back side. Okay, so this relationship is known as relationship of adjacency. This thing is known as linear data structure. And this element stored in a sequential fashion. Example of linear data structure are array, stack, queue, linked list. Okay. Now moving forward to the next one, non-linear data structure. The non-linear data structure, that means a data structure which shows the relationship of adjacency between elements. No, does not show the relationship of adjacency between elements are known as non-linear data structure. Okay, like rule number 1 is here, rule number 2 and 3 are connected with rule number 1. Again, rule number 5 and 6 are connected with rule number 2. That means there is no sequence in the memory. It's all in a hierarchical fashion. It can be a non-linear, non-hierarchical, and non-linear. It can be possible. So, in this, each and every element does not have one predecessor and one successor. Okay. Example of non-linear tree and graph. In this, data are not stored in a sequential fashion. Okay. Now, the first linear data structure is array. We have already learned it in CPU subject. So, can anyone tell me what do you mean by the array? Array is a collection of homogeneous elements. So, what do you mean by homogeneous? Okay. If you are going to take one variable A of type integer, B of type integer, C of type integer, D of type integer, what is the common in all four variables? They all have the same data types. Now, collect all four elements and put it in a one box. That bunch, a collection of elements, that thing is known as array. So array is nothing but it's a collection of homogeneous elements, and homogeneous means same data type. Now next one is array stored in a continuous memory fashion. Index starts from 0. What is the syntax of array? Data type, array name, size. If I'm going to take data type integer, then integer a size is 10. So that means in memory there is a portion, a 10 sequential portions, integer portions allocated in the memory, where the name starts with ARR, array. Okay, now let's see. Here, this is the array 10, 20, 30, 40, 50. Index starts from 0, A of 0, A of 1, A of 2, A of 3, A of 4. And the addresses are 1000, 1002, 1004, 6, and 8. Okay, so what happened here? The 1000, 2, 4, 6, 8 are the addresses, and if you mark each and every address has a difference of 2 bytes. Why it is 2 bytes? Because it is a type of integer array. Here I took size 10 but show only 5 because this is just an example. Okay, if you took size 10, then array from 0 to 9 index. Okay, now next, stack. Can you see that image? 79, 80, 81, 82. Okay, what happened? That each and every box, one box comes on another box, but in a sequential fashion. 79, 80, 81, 82. Is there any other another end to remove it? No. It is only one end. To insert the data, to remove the data. To insert the data, to remove the data. Okay. So stack contains the same thing. Stack contains one end. To insert the data, to remove the data. Okay, fine. Stack is a linear data structure. Stack is a linear data structure. And it contains only one end to insert and delete the elements. Now let me show another example. Please focus on my hand. If I took one box and that box is open with only one end, okay, top end. Okay, now put 10, 20. 30, 40, 50. Okay, box is full because my box size is 5 only. Okay, now box is full. If I want to remove something from this box, what happen? First thing is remove from the, okay, 50, then 40, 30, 20, 10. If you can easily understand this concept, then stack is very much easy for you, because this box is nothing but it is stack. Why it is stack, sir? Because it has only one end to insert something, one end to remove something. Okay, and what another thing happening over here, you the 50 is the last inserted element. See, 10, 20, 30, 40, 50. 50 is the last inserted element. It is going to be first deleted from the stack, like this: 50, 40. Last in, first out. Last in, first out. Stack follows LIFO manner. Last in, first out manner. Now let's see. Stack is nothing but is the linear data structure in which insertion and deletion occurs at one end. That end is known as top of the stack. The top is a pointer which pointing to the top of element of the stack. The insertion element is known as push. Deletion element is known as pop. Okay. And the last thing is stack follows LIFO manner. Last in, first out manner. Okay. Fine. Next one is queue. Here, see this example. This man, first come, first out. Okay. Again, watch it perfectly. This girl, first come, first out. What happens when you are standing in a queue of movie tickets? If you are the first one, you will take the ticket and get out from the queue. Again, your next person is take the ticket and out from the queue. Queue follows first in, first out manner. That means last in, last out. Both are same. Not going to confuse you. Just take a one thing. First in, first out. FIFO. FIFO. Let's take an example. So queue is a linear data structure in which insertion occurs at one end. That end is known as rear. Make sure you have to remember this. Rear. Rear is the end where elements are going to be inserted in queue. Front is the another end where elements are going to be deleted from the queue. The insertion deletion occurs in FIFO manner, first in, first out. I have already explained to you types of queue: simple queue, circular queue, priority queue, and double-ended queue. Okay. The next one is linked list. What do you mean by the linked list? Linked list is a collection of a node where each and every node contains two things. One is a data, second one is a pointer. Remember, one is data, second one is a pointer. Now see this example: data, pointer, data, pointer, data, pointer. What happened? The node, first node's pointer pointing to the next node pointer pointing to the another node. This thing is known as linked list. So here each and every node contains the same data type. Node of the linked list are not contain in a continuous memory. That means if the first node contains memory 2000 address, then second node can be 1000, 200, 350, whatever it is. It is not like array where each and every element stored in a continuous memory fashion. Okay. Types of linked list. Single linked list. See, in single linked list, the last node pointing to the null, and the first node of linked list is pointed by pointer first. We will see in a linked list chapter. Circular linked list. See, in circular linked list, the last node pointing to the first. Doubly linked list, where each and every node contains two pointer, one pointing to the next, another pointing to the previous. If I am a node, then node two pointers, right pointer pointing to the next one, left pointer pointing to the previous one. Next one is a tree. Tree is a maintain hierarchical relationship among elements. Hierarchical relationship, that means if we consider LJ example, then director, under director we have HODs, under HODs we have faculties, under faculties we have students. This is a tree. The tree maintain the hierarchical relationship where one designated node is there which is known as root. C. This is a root. B and C are child of node A. So A known as parent node. Next, This is D, E, C. If C is a parent, then child of C are F and G. We'll see it about tree in later. Okay, next one and last one is graph. So graph that shows the point-to-point relationship between elements. Data structure which is used to represent non-hierarchical relationship. It is a non-linear that shows non-hierarchical relationship among elements. Graph G contains pair of two non-empty sets. V stands for vertices, E stands for edges. So what do you mean by vertices and edges? Let me show you an example. See, is A, B, C, D, E are the node or vertex or vertices. A, B, C, D, E are known as vertices, and the link or line that connected between A and B is known as edge. B and C is known as edge. C and D that known as edge. Okay. Another thing, this example, maybe you people are interested in this because this is from the Facebook also using graph technology. How the Maria and Army are connected as a friend in Army's network. Nan is Army's friend. So what happened? Maria and Nan and all also friends. Okay, so these are the graph connected with each other. You can easily find out that John is a mutual friend of Army and Nan because John is a mutual friend of Nan because you are connected with John, you are connected with Nan also. So like this graph is going to be used, and the latest or the most frequently example where the graph is used is Google Map. In Google Map, what are you doing? If you click on from Prahlad Nagar to LJ, go straight, take right. Okay, so Prahlad Nagar is one node. LJ gate is another node. The link between of them is known as edges. Okay, so students, today we learned so many things like data structure, introduction to data structure, what is stack, queue, linked list, tree, graph, linear, non-linear. In our next lecture, we are going to see about the algorithm analysis. What do you mean by the algorithm? How we can measure that algorithm is good or bad? So we will see about it later. Till that, thank you so much. If you have any query, then contact me.